Alright, so yesterday we talked about the cell theory. Okay, today we're going to be going over microscopy. We're going to go over techniques, and we're going to go over how to draw a proper lab diagram, and then we're going to start the pre-lab activities for our microscopy lab, which we will be doing tomorrow. Okay, so tomorrow we will be going into the lab and using the microscopes to look at some things, getting the hang of how the microscope works, getting the hang of how to take pictures through the microscope with your phone, okay, because that's how you're going to do your lab diagrams, okay, because back in the day, people like me with zero artistic ability actually still had to draw lab drawings by hand, even though I sucked at it, okay. I could get it super focused. I was good at the microscope, but I always did poorly on my lab drawings because I just couldn't draw, okay. This is like, you've seen me draw, right? These are my people. Those are his arms, and those are his legs.
His arms come out of his ears?
I don't draw people with bodies, that takes too long. Well, I have to have some detail. Yeah. So, luckily for you, technology has improved vastly, okay? And so, all you have to be able to do is really take a picture through the microscope with your phone. It takes a little bit of practice, but in the end isn't too bad, okay? And then just label the picture that you took, because that's way better than most of us are going to be able to draw, okay, what we saw. So, I'll show you how to do that. It's pretty straightforward. And then we'll look at, like I say, the pre-lab stuff for the microscopy lab. So tomorrow, when we go into the lab, we will be looking at an amoeba, a paramecium, and the euglena. Okay, those will be the three things for sure, as well as, and this is like the most exciting one, the letter E. Okay, the reason that we have to look at the letter E is it's something that we know the proper orientation of. And that'll help us to see what a microscope does to the objects that we look at it through. Okay, I showed you that yesterday when I showed you how the light path goes through the lens, okay, and what happens to it. That's going to be important, by the way, for your hypothesis, okay, in the microscopy lab. Okay, so some microscopy things. Okay, this is a microscope. In case you didn't know, that's what this thing is that I'm holding. I want you to notice how I'm holding it. How many hands am I using? Right, that's why you have two. Okay? You have two hands so you can carry a microscope in a safe fashion. That's why. Okay? Always carry it with two hands. Because if somebody bumps you, okay, and they bump you hard enough, you might drop one of these. And they're not cheap. Okay? They're really not cheap. And they're also quite delicate, even though they're all metal. Okay? They're quite delicate and they're easily broken. So, we always carry them with two hands. One on the base and one on the arm. Okay, that's what this part is called. It's not the neck. Someone along the way has been telling you that. It's not. It's called the arm. Okay, so this is the arm. One hand on the arm, one hand on the base. Okay, that way if somebody does hit you, especially in the funny bone, because I've seen that happen, okay, like you turn around, you back up, and you bang your funny bone against something, what do? Yeah, you let go automatically, right? And then the microscope crashes to the ground and yeah, that's not good. All right, so just always carry it with two hands. Now, some of them actually still have the proper covers on them, but they're not new. Some of the covers have broken. This one is on its like second or third cover, and it's really just a big Ziploc bag. But it does a pretty good job of keeping the dust up. Well, this one doesn't, obviously, because of the hole. But okay, they're going to have a dust cover on them. Yeah, some of the newer ones will have a nice small plug on them. Okay, like this one does. Some of the older ones, you'll see a lot of like black electrician's tape and a big power adapter on the end. The reason is that people do not wrap the cords back around. Actually, this one's got a broken wire too. Okay? It's got black electrician's tape. That's because people don't wrap the wire back around and they carry it like this. And it drags along the ground until somebody steps on it and goes and yanks it out of the back of the microscope. So, please make sure that the power cord is wrapped around it when you're carrying it so that that doesn't happen. It's also a way that you could possibly cause you to drop the microscope. Okay? So we've got to be careful with these things because they're important and they're expensive. Okay, now, parts of the microscope. I'm never going to ask you to label a diagram of the microscope so you know what I'm talking about, okay, when I talk to you, okay? This is the eyepiece, or the ocular lens, because it has to do with your eyes. Okay, so in there is a lens that magnifies 10 times. Okay, then we have the body tube. Okay, that's this part here, and then we have the revolving nose piece. Okay, that's this, so it revolves. Okay, because there are 3 different sets of lenses on there. The 3 different lenses that are on there are the scanning power lens. That's the short one with the red stripe on it. The low power lens is the slightly longer one with the yellow stripe on it. And then there's the high power lens, which is the longest and most powerful, with a blue stripe on it. Everybody with me there? Okay, so the small scanning power lens magnifies 4 times, plus, or times, the ocular lens, so 4 times 10 for a total of 40. Okay, your low power lens magnifies 10 times, times 10 on the ocular lens for a total of 100. Okay, the high power lens magnifies 40 times, times 10 for a total of 400 times magnification. Okay, now below that you will see the stage, because that's where everything happens. Like in drama. Okay, stage where everything happens. All right, so on the stage you will see this little slide clip here. Okay, so you move it out of the way, place the slide in the slide clip, and then let it go. It'll close in and hold the slide in place, and allow you to move the slide around using these knobs right here. Okay, so I'm turning these knobs, and it moves the stage around so that I don't actually have to put my fingers on the stage and move the slide. Okay, because when you have to do that, you usually push the stage down, which affects the focus. Okay, because focusing involves moving the stage up and down. Right, so this eliminates the need to do that, and things stay in focus a lot better. Right, you guys probably didn't have microscopes that had that before, because well, they were the ones, if you were at John Paul II, that we left there when we left and came up here in 2006, and those were bought in 1998. Yeah, so they're like older than you. Anyway, okay, so these ones are a little better, but we got to take care of them. Okay, now the 2 focusing knobs are right here. This is the coarse adjustment knob, and this is the fine adjustment knob. Okay, the coarse adjustment knob, if you notice, it only makes about a half a turn before it locks. Okay, it moves the stage through its full range of motion. Okay, so it moves it a lot. That means that it very quickly changes the focus. You'll really only use that when you are on the scanning power lens and a little bit on the low power lens. You will not use the coarse focus knob at all on high power. Okay, and that's for a couple of reasons. First off, it moves so fast that you'll go right past the point of focus and you won't even realize it. Okay, and secondly, there is a danger with the amount of torque that can be produced by this lens, okay, that you could drive the microscope slide through the lens. Okay, now, most of them have a brake that we have set so that that can't happen. Okay, but just be mindful of the fact that you don't want to use this high torque knob, okay, when you are using the high power lens. Now, the fine focus knob bypasses the brake. So if you get to this point and you can't move anymore, but you haven't got it focused yet, then you can go to the fine adjustment knob and it will continue moving upwards past the brake, because there's not enough torque with this knob to do any damage. Okay, everybody follow me there. All right, so if you get to the point where, oh crap, I can't focus it, okay, well, move to the next knob. This knob will still continue to move. Okay, turn it in the same direction, it moves the stage the same way, okay, and you'll be able to get it into focus after that. All right, because there are some times where you hit the brake and you know you're this far from being focused. Okay, grab the fine focus knob and you'll be able to get there. Okay, now this actually does have a brake as well, but it's much further past where the other one goes. Okay, all right. On here as well, there's a light source. Okay, so down in here, that can be turned on with the switch on the back. Okay, on off. Very simple. Okay, yes, it's in the on position. Okay, questions on how that works? How many people have used a microscope before? Good. All right, then it won't be too much trouble tomorrow, okay, when we're using these for ourselves. Now, one other thing that does come up that we occasionally use, we won't use it in tomorrow's lab, but we will use it when we do our cell anatomy lab, has to do with this little knob here, okay, underneath. This is the iris, okay, and what it does is basically just opens and closes and lets different amounts of light in. Okay, there's also a rheostat, okay, to adjust the intensity of the light, but adjusting this actually allows you to improve the contrast of whatever it is you're looking at. That can be important if you're looking at a sample that hasn't been stained. Okay? All the samples we'll look at tomorrow are stained, so they're colored and quite obvious. But in the cell anatomy lab, we will be looking at our own cheek cells, and they will not be stained. And so as a result, you may want to adjust that a little bit when you get it towards high power, because it helps them to just pop, and then you can see them quite a bit better. Okay? Questions on the microscope? A couple of other things to do with the microscope that are on the board here. Okay, so we always return it with the scanning power lens in place. In fact, we always start on the scanning power lens. Okay, why do we start on the scanning power and not the high power?
Because you might not need to go lower, so you start there and you go. You might not need to go higher, so you start there and then you go higher if you have to.
Okay, I might not need to look at something on high power. That's one reason. Why else?
Easier to focus.
Easier to focus.
But you need to find the sample in the first place.
Yeah, you got to find it. Okay, guys, if you're looking through the high power lens, okay, this is kind of what happens as you go from one power to the next on the microscope. Okay, the scanning power doesn't magnify very much, but it sees a very big area. Okay, so when I'm looking on the scanning power, I see an area this big. In fact, it's 4,000 micrometers across. That's 4 millimeters. Okay, 4,000 micrometers across. When I go to the high power lens, okay, that area becomes more greatly magnified, which means I see less of it. In fact, I only see an area that's about 1,600 micrometers across, so maybe only about that big. When I go to the high power lens, I magnify 400 times. I see an area that's only 400 micrometers across. Okay, so if what I was looking for is out here, I won't see it. Okay, if I start on the high power lens. So what we have to do as we're looking through the lenses is, once I find what I'm looking for, I'll use those little knobs on the bottom of the stage to move that thing into the center. Because as you look through the microscope, this is kind of funny, as you look through the microscope, you'll actually see a big black thing that points towards the middle. It's called the pointer. It's actually just a small brass wire, okay, that's in there, okay, and points inward. But it points towards the middle. It's supposed to be there. Okay, I say that because I once had a group bring me 6 microscopes in a row. Just critter, this one's broken. Just critter, this one's broken. Just critter, this one's broken. I'm like, what's wrong with these things? They're like, well, there's this big black thing in the middle. Point? Oh, that's what that is. Yeah, okay. It's supposed to be. Okay, so when you see this thing, don't freak out. It's supposed to be there. Okay, it marks where the middle is. Whatever you're looking at, you want to put it on there, so when you switch to a higher magnification, that thing will still be where you can see it. Okay, and when you adjust that magnification, okay, remember that when you go to high power, you really need to make sure that it's on the end of the pointer so that you can still see it. Okay. Okay, so when you're done, make sure you return it with the scanning power lens in place, because people are going to assume that's what's going to be in place. They don't always check. Okay, and they're going to grab the coarse focus knob and start cranking away. Okay, you want to make sure that you've got that scanning power lens in place. Okay. When you are cleaning the lenses, because occasionally you'll notice that your lens looks a bit dirty. Okay, if that's the case, there's special paper to use to clean the lenses. Okay, it's called lens paper, and I'll have some at the front. Please don't use your shirt or, okay, because that's gross. Okay, like someone will get pink eye. Okay? Don't do that. Okay? Yeah, so don't use anything other than the lens paper to clean the lenses. And when you use the lens paper, okay, use like one part of it, wipe, and then use a different part of the paper to wipe again. Because any grit that it picks up, we don't want to put back on the lens or grind into the glass. Because even a tiny scratch on a lens will look huge. Because what does the lens do? It magnifies the scratch. Okay, so we don't want to have that happen. Make sure you use the lens paper, okay, and you're always using a different part of it. Right? Realistically, the only lens you should really need to clean should be the eyepiece. all right? Because people, they get their skin oils on and stuff like that. It happens. Okay, the objective lenses, they really shouldn't get all that dirty, but if you want to give them a quick wipe too, that's fine. Okay, you'll know if they're dirty, it'll be obvious. Okay, questions on the handling and use of the microscope? Okay, now, I was telling you about what we call the field of view. That is, what the area is that you can see through the microscope. Okay, so you're going to want to copy this down somewhere. Okay, through the scanning power lens, which gives us a total of 40 times magnification, we can see an area of 4,000 micrometers across. Okay, that's equal to 4 millimeters. Okay, now this little symbol here is mu. It's the Greek letter M. Okay, because we can't use mm because that stands for millimeters. That's 1,000th of a meter. Okay, a micrometer is 10 to the minus 6. Okay, a millimeter is 10 to the minus 3. Okay, a micrometer is 10 to the minus 6 meters. Right?
This is all time.
4,000. Oh, sorry. It's 1,600. Oh, I erased it. 1,600 micrometers. Okay, and for the high power, it is 400 micrometers. Okay, it's the magnification of high power is 400 times, and the field of view is 400 micrometers. Now, the reason we need to know those fields of view is because part of a lab diagram is writing out what size the object is, or how big the object we're viewing through the microscope is. Knowing how big the area I can see is helps me to estimate the size of the object, and that's all it is. It's an estimate. Okay, we're not looking for exact numbers here. Okay, so if I'm looking at something through the scanning power lens and it looks this big, how big is that? In micrometers. 800 to 1,000, somewhere in there. Okay, that's all you have to do. Okay, you're just estimating the size of the object. It doesn't have to be an exact calculation. Now, if you tell me that's 2,000 micrometers, I'm going to go, you're a bad estimator. Okay, it's between 800 and 1,000 micrometers. Okay, that's a reasonable estimate. That's all you have to do for the estimation of size. Pretty straightforward. All right, so that's the stuff we just went over there, and we talked about estimating the size, so we can skip over that. Okay, I want you guys to quickly answer those 3 questions, and I'm going to set up some stuff on lab diagrams here in just a minute. Lab diagram formats. Okay, so the proper format for a lab diagram is as follows. Your name and the date go in the top right-hand corner. Okay, your name and the date go in the top right-hand corner. So you might just want to, like, on your paper, just draw like a small picture of this. Just draw kind of, like a square representing a sheet of paper. Okay, name, date. They go up here. Okay, the diagram itself, we want to take up as much of the page as possible. Incidentally, a lab diagram takes up an entire page. Okay, you should never have more than one lab diagram on a page of paper, okay, or on a page in a document. Okay, each one takes up a full page. All right, so we've got our organism. Okay, it takes up as much of the page as possible, and it's going to have labels. Those labels, as you can see, all go out to one side. It can be right or left, as long as it's to one side. Since most of us are right-handed, it's logical to have them on the right-hand side. Okay, if you're lefty, you can go the other way. Okay, so we got all of those lines. They're all going out. And what do you notice about all of these lines? They're straight. Yeah, they're horizontal. Okay. What I don't want to see is a lab diagram that looks like this. That's confusing, and it looks bad. Okay, it just looks bad. It looks disorganized. Okay, we don't want our lab diagram to look like that. Now, occasionally, it didn't happen on this particular thing, but occasionally you might have 2 structures that are kind of right beside each other. So let's say we had this structure and this one back here that we were trying to label. Well, obviously I can't make a straight line from this spot over here because that would overlap this existing label. So if that happens, okay, then what I do is I make a line that is diagonal, and then I make a line that is horizontal after that. Okay, but our labels should always be on the end of a horizontal line. Okay, just makes it look neat and organized. Okay, under the diagram itself is where the title goes. That's weird. Titles usually go at the top, but on lab diagrams they go at the bottom. Okay, so we would have the title. In this case, this is a worm from phylum Cestoda. Okay, it's a flatworm. And it is viewed under 50 times magnification. You won't have 50 times. You'll either have 40, 100, or 400. Okay, those will be your only ones. So 50x or 40x, 100x, or 400x magnification, and then the estimated size. Okay, this thing was 1.5 centimeters long, so a lot bigger than anything we're going to be looking at tomorrow. Okay, all of our stuff is going to be in micrometers. That's what your lab drawings should look like, okay, in terms of format. Now, I'm going to walk you through how you do one. Okay, everybody with me there? In fact, I think I'll have you walk through it with me. I'm going to get the Chromebooks right now so you can do the same thing that I'm doing. All right, so we've got our Google Doc open that we're going to use for our lab report. We're going to put our lab drawings in here. You can see here under observations it says, see lab drawings on following pages. All right, so I'm going to go down here, and I'm going to go, oh, I already have it there. Okay, look at that, I was so okay, so I'm just going to get rid of that. Okay, start again. So I've got this second page. I'm going to go down to the second page, and I'm going to go to Insert, Image, okay? Actually, I'm going to go to Insert Drawing. Okay, Insert Drawing, and I'm going to go over here to View. Okay, then it opens up Google Drawings, which is like the worst graphics program ever written, okay? But it'll do for what we need, okay? So what we want to do here, now that we're in Google Drawings, is we want to go here to where it says Image, because you will have an image, the pictures that you have taken in the lab. You'll want to save those into your Google Drive after you take them, okay? Or send them to yourself, whatever. Okay, so I'm going to click on Image, and I'm going to just go into my Google Drive here because I have a picture of an amoeba that I'm going to use. Okay, so I'm just going to click on that, and it will insert it into my drawing, like so. Now, I want this to be so I can label it all to one side, so I'm just going to quickly rotate this thing by grabbing the rotating thing here and just flip it. Okay, and then I'm going to move it over like this. Okay, so now it's over on the right-hand side. Okay, I should be able to now draw lines across, put my labels on, okay, as I go. Right, so I'm going to use the little text box feature here. Okay, and I'm going to put my name and the date over here. It's supposed to be in the top right-hand corner. Okay, and it is October 9th. Okay, so now I've got my name and date over there. Now I'm going to start drawing my lines out from the various structures in the amoeba. Right, so I'm going to label this thing. I'm going to draw a line and make it as straight as possible over to the side. Okay, I'm just going to draw all my lines right now that I'm going to need. And again, making them as straight as possible. Okay, I'm trying to take them all out to about the same spot. Okay, that way I'm kind of planning what my lines are going to look like. If I had to do one of those diagonal ones to a horizontal one, I would do that like this. Okay, so let's say I wanted to, I don't know, label this structure here. So I would draw up and then over like that. Okay, so now I'm going to put in a text box at the end of each one of these things and put in the label. All right, so that's going to be a food vacuum. I don't expect you to know that stuff yet because I haven't taught you what all the parts of the cell are yet. But, okay, for right now, that's what that is. All right, then I'm going to put in another text box on the end of this one. Okay, and that's going to be a water vacuum. Actually, it's just going to be a vacuum. Going to be something else. Okay, and just keep doing that onto the end of all of my labels. So this would be the nucleus. And this would be the cell membrane. Okay, and you can see that my labels are a little bit off right now, and that's okay. I'm going to move them in just a minute. Okay? Alright, so now I have my arrow here. Okay, I'm just going to take these and move them up a little bit, move them over so they're kind of on the end of each label. Right, just so it looks a little neater than it did where it actually went on. Okay, something like that. So now I've got my lab drawings. Now I'm just going to go to Actions, okay, and I'm going to say make this into a type of picture file. Right now that it's all finished, okay, I want to download it. Probably just a JPEG because that's going to be the smallest file type that we can use. Okay, so save it as a JPEG. Okay, there it goes. So now it's right there. Okay, and I'll just say show in folder so that it shows up here. Okay, so there it is. And then I'm going to go back. Save it closer. Oh, there we go. Okay. Actually, it inserted it even without me saving it as a file. Okay, they put it in here. Kind of a little bit off the bottom there. I didn't check the bottom. All right, but you can see I've got my. Oh, I forgot to put in the title and stuff at the bottom. So I got such a rush to show you how to put it in here. All right, let's try that again. Now you kind of saw how I did everything, right? You do everything with text boxes. Okay, put the name and everything underneath. Just make sure it doesn't get cut off on the bottom. Okay, you can resize the object. It doesn't need to stay in the same. Like if you stretch it or squish it, I'm not going to know. It's an amoeba. Okay, no two amoebas look alike. They're like snowflakes. Okay, so don't worry about if you have to skew it a little bit to make the lab diagram fit. Okay, so you have one of those on each page. So I start another page down below that for my next diagram, and so on and so forth. Okay, everyone follow on how to make the lab diagrams. Okay, so they insert nicely, and remember, they should be one big page. Okay, take the pictures at as high a resolution as possible on your phone because you may need to blow them up and crop them a little bit. Okay, if they end up being kind of small. Okay, so just consider that when you're taking your pictures and inserting them. If they get really blurry, okay, you may have to consider coming in and taking another picture. Okay, all right. Questions on the lab diagrams? Everybody's okay with those? Okay.